Anthelmintic resistance. When will sheep dewormers start to fail and no longer stop parasitic worms? A parasitic worm is called a helminth. There's a lot of different types of parasitic worms, but they mostly can live on the ground and also inside a sheep and draw the blood out of the sheep. Most importantly, they depend upon moisture to reproduce. The adult worms will lay eggs into the pasture, and for the eggs to hatch and for the larvae to be able to migrate back up where they can be eaten by other sheep, there has to be a lot of rainfall. So if you live in West Texas or Utah or Colorado, you're not going to have nearly the problem as we do in Tennessee because we have a much higher rainfall. Hot, dry weather will kill the larvae and will stop the infection of sheep, but humid and moist weather that's warm is perfect breeding ground for them. The eggs are so small that they can only be seen with a microscope. This is the egg of a Haemachus contortus, which is the barber pole worm, and it has to be counted or looked at under a microscope. The adult worms can be up to an inch long, and they can literally draw all the blood out of a sheep and kill it. So the solution to kill these worms is to use chemical dewormers. And since the worms are called helminths, a dewormer is called an anthelminth. So an anthelmintic is an anti-parasite drug or chemical that will expel the parasitic worms, which are called helminths, and other internal parasites from the sheep's body. There are several different types of anthelmintics or dewormers, but they fall into three broad categories. Now, I don't use this stuff, so I really can't pronounce the words correctly, but the first category is called benzimidazoles. Examples of benzimidazoles would be Safeguard and Panacur, and Valbazin. The next type of dewormer would be levamisole, which an example of that would be something called Reumatel. The third group is called macrolytic lactones, which would be such things as Ivomec and Cydectin. And there's other trade names for different kinds of dewormers or anthelmintics. But as close as I want to get to them is just their names, and I'm having a hard time with that. So if these are anthelmintics, what is anthelmintic resistance? Under the Wikipedia article on anthelmintics, if you scroll down, you'll get to a section that talks about anthelmintic resistance. Anthelmintic resistance occurs when the parasite's DNA changes that renders it insensitive to a previously effective anthelmintic drug. This is a huge problem for small farm animals with a rumen like sheep. The article goes on to say there was a database of published and unpublished anthelmintic resistance research in Europe on these nematodes that was collected in 2020. They collected nearly 200 publications that represented over 500 studies in 22 countries over a 40-year period. The results from these studies since 2010 show that there was a resistance to these anthelmintic drugs of 86% for all the benzimidazoles, 52% resistance for the moxidectins, and 48% resistance for the levamisoles. On top of that, all of the major gastrointestinal nematodes or worms survived treatments from these drugs under all these different studies. So again, these worms are completely resistant 86% of the time to benzimidazoles, 52% of the time to moxidectins, and 48% of the time to levamisoles. They're just not working anymore. So to get more information about these studies, I clicked on this link 14 down at the bottom of this article, and it gave me a link to the actual study in Europe about the increasing importance of anthelmintic resistance in European livestock. Clicking this link took me over to the actual document itself, and it's being hosted at the NIH on the National Library of Medicine. And scrolling down and looking at this, it'll put you right to sleep if you try and read it yourself. So I'm going to just give you the high points of it. I read things like this to help myself get around insomnia at night, I suppose. But down at the bottom of the page, it's telling you how many studies were made and all the publications. And so this information is very well backed up, but only from Europe. And that's a good question. Why don't we have a USA study? What's going on there? So a picture is worth 1,000 words, and if I can't really understand the study that well, I can at least look at the pictures. This chart shows the difference between BZ, which is the benzimidazoles, LEV, which is the levamiazoles, the MLs, which is the macrocyclic lactones, and the MOX, which is the moxidectin. On the left side of the chart is the prevalence of the anthelmintic resistance. And when it hits 100%, it means that the worms are completely resistant to any of these drugs or chemicals. You can see that in the 1980s, there was a very low rate of anthelmintic resistance. Yet by the 2000s and 2010, most of them were up to about 50% of not working anymore. So the parasitic worms are mutating and getting around these chemical dewormers, and they're just not working like they used to. In this chart, the BZs are the benzimidazoles, while the MLs are the macrolytic lactones. And CH stands for Canton Helvetica or Switzerland, while the UK stands for the United Kingdom. The prevalence of the AR or anthelmintic resistance is on the left side. The years are on the bottom. And what you're seeing are all the dots that are out there. There's like an average line for each one of these studies. And you can see that the prevalence is starting to reach 1 for all these lines. And it looks like it's starting to converge around 2020 or 2025. I don't think we've got a lot of time left. I really think they're going to fail in the next 5, 10, 15 years. So why aren't there any studies like this being done in the United States? And I think the answer is that Big Pharma has control over the U.S., and so they're never going to study the fact that their own parasitic worm medicines are starting to fail. So what's Big Pharma's answer for all this? Because they want to keep selling these chemicals to us. So what is it? So what they have now is something called refugia, and that is that there are resistant parasites that will no longer be affected by their chemical drugs anymore, and there are these susceptible parasites. So what they tell you to do, and I'll try and say this without laughing, is they tell you that if you treat the entire herd so no refugia is preserved, then all the susceptible parasites will die, and only resistant parasites will remain to breed, and they'll get right around your drugs. But if you only treat half your herd and you leave the susceptible parasites in them as well as these resistant parasites, well then next time maybe their drugs will work, at least on the ones that are susceptible. I'm sorry, but this looks just absolutely insane to me. I don't understand how anybody could think this would work. And maybe it's not meant to work. Maybe it's just meant to sell more drugs and make more money. Because Big Pharma is not about making people healthy or making healthy animals. It's about selling more drugs and making more money. So what's their answer, and how are they going to keep making all this money while doing it? Well, it gets worse, a lot worse. And here's where the NIH comes out and tells us how vaccines could be used to control the barber pole worm. In case you didn't know, the NIH and USDA and all that, it's run by the big corporations. It's not run to benefit us at all. So what do they have planned? Believe it or not, they're coming out with a vaccine that will stop the barber pole worm. They're already using this vaccine in Australia, and the problem is it takes a lot of doses to make it work. They have to inject a sheep every 6 weeks with these vaccines to have a chance of stopping the barber pole worm. They have to start with 3 initial vaccinations and then continually give more vaccinations every 6 weeks so they can keep these sheep alive. That's a real cash cow. Here's the regimen for lambs, with V1 through V6 standing for the 6 different vaccinations. For hoggets or 1-year-old sheep, These may only have 5 vaccinations, one every 6 weeks. This is for year-old ewes, and notice that V5, it says after vaccination number 4, V5 is to give vaccinations at 6-week intervals. I guess until they fall over dead or something. And here's a vaccination schedule for 2-year-old ewes, if they make it that long, and then you just continually give them vaccinations every 6 weeks. They are vaccinating animals, including cattle, just everything now, with Big Pharma behind all this. So if there's ever a time for you to raise your own animals to get away from this, now's the time. And you have to get away from these chemically dependent sheep breeds. So really the only way you can do it is with a truly parasite-resistant breed. And let's go over those real quick again. So the parasite-resistant sheep breeds are Barbados Black Belly, Florida Cracker, the Gulf Coast Native, and the St. Croix sheep are all parasite-resistant. The somewhat parasite-resistant are the Katahdin and the Royal White. The non-parasite-resistant sheep breeds are the Dorper, the White Dorper, the Dorset Horn, and the Wiltshire Horn, and practically every other breed of sheep. Now, if you live in the western United States or someplace that has a very low amount of rainfall, you could probably raise just about any type of sheep you want, and you may not have to use chemicals at all. But if you live in the southeast United States or any place with a lot of humidity, you're going to have to deworm these sheep. And you're going to have some sort of way to handle these worms, or else it's going to kill all your sheep. And if you're going to be pumping chemicals down your sheep, why not just buy your lamb meat down at the supermarket? It just makes more sense because that's exactly what's on the shelf down there. And if you're raising chemically dependent sheep, don't even think about ever getting them certified as USDA organic. Here's a list of the allowed and prohibited substances for organic production of livestock by the USDA. And if you scroll down the list to number 23, you'll find that these chemical anthelmintics or parasiticides cannot be used for any kind of slaughter stock. You can't sell it if the animals ever had this in it. It can be used for some of the breeder stock, but just read this label. This is going to tell you what you can and can't do with it. And so this excludes any sheep breed that relies on chemicals to survive from ever being sold as organic. And while St. Croix and some of these other parasite-resistant sheep breeds may not bring as much in the commercial market because they're a little bit smaller, they will definitely bring a lot more money in the organic market because you just can't find it. These are the only ones you can do, the only ones you can grow in the southeast that you can grow without chemicals. And to top it off, these chemicals that these other breeds of sheep depend on to survive, they may start failing. It really looks like in the next few years they're just not going to work anymore. So I'd like to encourage you to raise parasite-resistant sheep for your own health, but also for your own food security. Thanks for watching the video.